Last class we had discussed about refraction through prism and we had obtained the refractive index of a prism. Now, if the prism is very thin, what happens? That is deviation through a thin prism. So it's basically the same formula that we have written for prism that we are going to use, but the main difference is if the prism is very thin, then the minimum deviation is also very small. So sin A plus delta m by 2, delta m is very small, then you can write this almost equal to A plus delta m by 2. That's an assumption because for very small angles, sine can be or sine of an angle can be simply written as the angle itself. So this can be approximately equal to A plus delta m by 2 and sine A by 2. Now when I talk about thin prism, A is very small. Normally for a prism, A is taken as 60 degree. That is the equilateral prism, A will be taken as 60 degree. But this is a very thin prism. So it need not be 60 degree, it will be some small angle. So sine A by 2 will be approximately equal to A by 2. So in our refractive index formula, we can write, in place of this, we will write this. So A plus delta m by 2 and in place of sine A by 2, we will write just A by 2. Now when we solve this, it will go that side. So you get it as A plus delta m by 2 into 2 by A. 2 goes off and what do we get? We will get m is equal to A plus delta m by A. So from this we have to obtain what is delta m, minimum deviation. So delta m can be written as cross multiply Na minus A. Delta m, A goes that side and this is cross multiply. So you can write A into n minus 1. So delta m can be written as A into n minus 1. So this is the formula of minimum deviation or deviation through a thin prism. So all what you have to know is the angle of prism and the refractive index of the prism to obtain the deviation or the minimum deviation of a thin prism. Now we will solve a problem based on the prism formula. I'll read out the question for you. Find the angle of incidence at which a ray of monochromatic light should be incident on the first surface AB of a regular glass prism ABC so that the emergent ray grazes the adjacent surface AC and the refractive index of glass is given as 1.56. I repeat the question. Find the angle of incidence at which a ray of monochromatic light should be incident on the first surface AB of a regular glass prism ABC so that the emergent ray grazes the adjacent surface AC and the refractive index is given as 1.56. So first, let's draw the figure. You have a prism. It's a regular prism. And if it is a regular prism, we know that the angle of the prism has to be 60 degree. It's a regular prism, so this angle is 60 degree. Now, a ray of light is coming and falling on the face A, B. So let's draw a normal and you have a ray of light coming and falling on AB. And this angle, let's take it as angle of incidence. Now what is said? The refracted ray goes out of AC or it just grazes through the surface. So that means it may not be a straight line. It's going little like this and then it grazes through the surface. So you have now the normal here. Okay. Now this is how the figure looks like. So this is your angle of emergence, grazes through the surface. Now as we did, this will be R1 and this will be R2. Now if it has to graze through the surface, that means the angle of incidence at that interface should be the critical angle. So I take this as critical angle because that is critical angle, so I take it as C. And what will be this emergent angle? This is a face and this is perpendicular to it, so this means this has to be 90 degree. So we know what is the emergent angle and this has to be critical angle. So first step is to find the critical angle. So we have the formula that we have obtained for critical angle, that is sin C is equal to 1 by n. This is the formula of critical angle. Sin C is equal to 1 by n. Now if this is the formula of critical angle, from this what is sin C? It's given in the question that refractive index is 1.56. So we get sin C is equal to 1 by 1.56, and when you solve C, it is sine inverse of 1 by 1.56 and that comes to 40 degree. When you solve it, it comes to 40 degree. Now in this figure, when you extend this line and this line, this is the exterior angle of this triangle. We already know this is 60 degree. Now if this is 60 degree, for this quadrilateral, 60 plus this, let me take it as x, 60 plus x is equal to 180 degree. The same way, this is a straight line, so this angle plus x should also be equal to 180 degree. So 60 plus x, 180 degree, x plus unknown angle, 180 degree. That means this has to be 60. 60 plus x, 60 plus x, it's the same. So if this angle is 60 degree, you can write R plus C. That is, we can write R, that is exterior angle property, R plus C is equal to 60 degree. We know what is C already, that is 40 degree. So we can write R plus 40 degree is equal to 60 degree. So R is equal to 60 minus 40 and that is 20 degree. So R is equal to 20 degree, that is angle of refraction at the first surface. Now we have to find the angle of incidence for which all these things happens. So we know refractive index n is equal to sin I by sin R. So we have to find I. So sin I is equal to n into sin R. We have found out. So you can write 1.56 into 20. Sorry, sin 20. And when we solve this, that is 1.56 into sin 20, we get it as 30, that is I. I becomes sine inverse of this. And we get I is equal to 32 degree when we solve that. You have to first solve this and then take sine inverse to get I. Or simply you can write sine I is equal to whatever you obtain. So this is how we find the angle of incidence for which the conditions of the questions satisfy.